remember how yesterday we defined our trigonometric ratios? We discovered them on GSP. We used SOHCAHTOA to help us. Remember, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Today what we're going to be doing is given the angle using trigonometric ratios to find the missing side lengths of a triangle, and working in the opposite way, given the side lengths of a triangle, using the trig inverse functions to find the missing angle. Before we get started, let's take a look at this. Looking at these two triangles, we know they're similar because they both share the same angle measures. We know they both have an angle measure of 90 degrees and 37 degrees. We can also see that the sides are proportionate. Here, 12 is proportionate to 3, 15 is proportionate to 5. Therefore, the trig functions are constant for the given angle. Let's take a look to understand this a little further. We know sine of 37 in this triangle here is 12 over 15, and in this triangle here is 3 over 5. Well, 12 over 15 simplifies to 3 over 5, and both of those fractions are equivalent to 0.6 as a decimal. Now, if you wanted to do this at your seat with your graphing calculator, you would turn it on, clear everything, so whatever's on your screen, make sure to clear that. You can go to second, draw. Notice how above the word draw you have trig in a yellowish green color. You would click on 1 where it says sine, open parentheses, plug in 37, close parentheses, and you'll notice you get 0.6. The reason behind that is because these ratios, the calculator stores these ratios, these constant ratios, as a decimal. So we know that any right triangle with this angle of 37 would have a sine of 0.6. Looking further, let's go ahead and use our trig functions to help us find missing side lengths. So in this first one, you can see that we're given the angle 64. We're given the side opposite, which is x, that's what we're trying to find, and the side adjacent, which is 11. Therefore, we would set up our equation as tangent of 64 equals x over 11. We could write this as a proportion, cross multiply, and get tangent of 11 times the tangent of 64 equals x. Now to do this in your calculator, you would type in 11, type multiplied, again go to second, draw, you're clicking trig, you would move down to number 5 where it says tangent and plug in 64. Close parentheses, hit enter, and notice you get that x, our missing side length, is 22.55 units long, or just 22.55 is fine. All right, let's look at another one. Here, notice you're given 29, the angle of 29, you're given the side adjacent to it and the hypotenuse. Therefore, we're going to use cosine of 29 equals x over 29. We can multiply by 29 on both sides to cancel it in our denominator here. To plug this into our calculator, you would do 29 times second, draw, again you're clicking trig, cosine, which is number 3, tab down to that, hit enter, 29, close parentheses, hit enter, and you'll notice you get that x equals 25.36. We're rounding to the nearest hundredth for these, as it says in your directions. All right, looking at the next one. Here we have the angle 41, and we have the side opposite to it, the side opposite the angle and the hypotenuse. Here, since we have the opposite and the hypotenuse, we're going to use sine. We can set this up as sine of 41 equals 24 over x. We can multiply by x on both sides to clear it from this denominator and therefore have it pop up over here. The reason behind that is because we're going to then divide by the sine of 41. Remember, the sine of 41 is just the ratio of the side length opposite of that angle to the hypotenuse. And remember, all right triangles that have an angle of 41 are similar, therefore that ratio is consistent. So we can technically divide by this sine of 41 because it's just a decimal, a constant decimal that our calculator stores. Now to plug this into your calculator, you would do 24 divided by second trig. You're going to click the first one because we're dealing with sine, 41, close parentheses, hit enter, and you get that x equals 36.58 units, or whatever it is that we're talking about. So in all three of these examples, we were given the angle measure, and looking for a missing side length. In the next few examples, we're going to be doing the opposite. We're going to be given the side lengths, looking for the angle measure. Now remember, the trig function takes an angle and gives us the ratio of the two sides with respect to the angles. The inverse of any function does the opposite. Therefore, the inverse of any trig function does the opposite. It takes the ratio of the two sides and gives us the angle measures. So let's go ahead and look at an example of this. Here in this example, we're given the two sides, 8 and 14, and we're looking for angle B. Now, angle B, of these two sides, what we're given here is the side opposite angle B and the side adjacent. So we're going to say tangent of B equals 14 over 8. Now we're looking for B, so we need to undo this tangent. So let's recall back to algebra. In algebra, we know that x to the negative 1 is really 1 over x. So that means that tangent to the negative 1, we read this as tangent inverse or inverse of tangent, is really 1 over tangent. So if we were to multiply inverse tangent times tangent of b, what we're really doing is if we write this as 1 over tangent, we're dividing or we're clearing the tangent function, which would result in just b equals. So you want to keep that in mind here when we go ahead and look at the rest of these examples. So if we're trying to find if we're trying to find the angle B and we're given that tangent of B equals 14 over 8, we're going to use the inverse tangent function. So we're going to multiply tangent of B by inverse of tangent. Remember, whatever you do to one side, you do to the other. You could rewrite this as B equals the tangent of 14 over 8. Now, this is going to give us an angle measure. Remember, we're using the side lengths and the inverse function to find the angle, to go backwards. So in order to do this, you're going to go to second, draw in your calculator, so click second, draw. You're going to go all the way down to number 6 that says tan negative 1, remember tangent inverse, click there, hit enter, plug in 14 divided by 8, close parentheses, and you'll notice that it spits out an angle measure. So here we can say that angle B equals 60.3 degrees. And remember, here in 6 through 8, we're rounding to the nearest tenth, and we're finding the measure of angle B. So again, the inverse of any function does the opposite. So if we multiply the tangent times tangent inverse, here it's going to just give us the angle, which is exactly what we're looking for. Let's look at another example. Here, if you notice, we're given the side, we're looking for angle B, we're given the side adjacent to it here, excuse me for all the coughing, and the hypotenuse here. So here we're going to say that the cosine of B equals the adjacent side, 25, over the hypotenuse of 30. Then from there, we're trying to undo this cosine of B. So we're going, just undo the cosine to find B. So we're going to multiply by the inverse cosine. The inverse cosine cancels, and we're just left with B equals cosine inverse of 20, or the inverse of cosine of 25 over 30. So again, let's go to our calculators. We're going to go to second, draw, toggle down to number 4 on cosine little negative 1, inverse of cosine, hit enter, plug in 25 divided by 30, close parentheses, hit enter, and you'll notice B equals 33.6 degrees. So again, we're using the side lengths here, using cosine, the inverse of cosine to find that angle measure. Last example here. Looking at this last example, we're looking for angle B, we're given the side adjacent to angle B and the hypotenuse. So again, we're going to use cosine of B equals the adjacent side, 7, over the hypotenuse. Then from there, I want to solve for B. I'm going to multiply by the inverse of cosine. Therefore, it's going to cancel, and I'm going to be left with B equals the inverse cosine of 7 over 39. Now to our calculators, we're going to go to second, draw, toggle down to inverse cosine number 4, hit enter, plug in 7 divided by 39, close parentheses, and we get that the angle measure of B is 79.7 degrees. Now, just a few things to talk about before I let you guys go ahead and work on your classwork. What students struggle with most with trig functions and inverse trig functions is remembering that our calculator stores this ratio as a decimal. So if two triangles have two right triangles share one angle in common, by angle, those triangles are similar, and therefore their ratios are consistent. So something to keep in mind there. What you're going to do after this, Ms. Kraft is going to hand you a worksheet on using trig functions to find missing side lengths and angles. That's your classwork. The answers are provided on there for you so you can check as you go. And then you have another worksheet as your homework. So do the best you can. I'm going to also upload this video onto Google Classroom. That way you can check and use it at home whenever you need it. Be good. I hope you guys have a great day and have a good weekend. Take care.